All right. So yesterday in math or in chemistry class, not math, chemistry, we talked about we've already talked about Democritus' law of conservation of mass, and we've talked about 4.3, 4.4, and 4.5. Okay. The students were given these notes to put in their notebook, and they were asked to answer these questions in their notebook. Okay. Then we talked about, very briefly, we talked about how Dalton was the first person to provide scientific evidence for the atom, and that they combine in whole number ratios, and the atoms of different elements are actually different from each other. And it was widely accepted because it had evidence, right? And at the time it was called a theory because it had evidence. We still refer to it as a theory because it had evidence at the time. Now we have new evidence that has caused us to update the atomic theory, but we've gotten no evidence to make us refute the atomic theory. All right, and then we talked about cathode ray tubes in 4.11, and there's a video you can watch. And we talked about Millikan's oil drop experiment, and basically what the cathode rays, Thomson and J.J. Thomson and some other scientists figured out that there were particles that could be transferred through a vacuum, and they were called cathode rays. And through testing, they showed that they must be particles, not electromagnetic waves. And J.J. Thomson showed that they had a very small mass and they were negatively charged. Millikan showed, he actually calculated the exact charge of the electrons. So J.J. Thomson, his model, he called it the plum pudding model. Today, we might call it the chocolate chip model. Basically, the idea was you had a positive sphere with negative charges inside of it. And he had to come up with this because they knew atoms were neutral, that just atoms in general are neutral. They don't have any charge. So the only way they could have a negative particle inside the atom is if there was also a positive charge that balanced it. And so this was his model, and it fit the evidence that they had come up with. It Dalton's evidence that was still verifiable, and the new evidence from Millikan and J.J. Thomson, so it fit. Now, a few years later, one of Thomson's students, Ernest Rutherford, he did an experiment with gold foil where he shot positive alpha particles through the gold foil. Now, these are basically a helium nucleus, so they're extremely tiny. And if you use the plum pudding model, then the alpha particles should just go straight through. Every single one of them should go straight through. But what they found is some of them were deflected at an angle instead of going straight through. And some of them actually bounced back. And so they had to have some way of accounting for that, right? And so a new model of the atom was developed where you had a tiny positive center of the nucleus where pretty much all of the atom's mass was. We call that the nucleus. And then around that was mostly empty space with negative electrons. All right. And so then the idea was the students would have glued these notes in, okay, and then they would have worked on these questions. All right. And that was, again, this is for Tuesday the 26th. Sorry I didn't post it sooner. My planning got called. I had to cover a class. All right. So have a nice day, and hope to see you soon.